Hello. In this example, we will see time-related models of linear programming, and I'll use the question supplement chapter 14, question number 26. So please read the question before you start watching the video. So what are the steps to understand the problem and using visuals, especially for time-related models? That's what I would like to demonstrate in this video. So the story is telling us about a store that have certain requests to borrow a certain amount of cash. Also, they have revenues, and your goal is to minimize the borrowing cost. So first of all, let's visualize the story using pictures. So here we have months July to December. And as a first step, we understand that these are the revenues that the store have in each month. So for example, in July, they will have 20,000, August 30,000, and etc. You can see it in the table that was given to you in the problem itself. We also see that the problem itself providing us the liabilities in each month. And let's define the liabilities as outflow from each month. We need to pay those liabilities. So we can see each month the amounts as per the table provided in the problem. The next step is it says that they can borrow in the first month, they can take a loan that carries 11% interest, and they must pay it back at the end of December. So in order to do that, I will define X1 as the amount of that specific loan, and that will be additional cash that they have available as a revenue. It's not a revenue, it's actually a loan, but that's additional cash that's inflow into July. Similar to that, they also can take another loan each month and pay it each month. So it's not like for 6 months loan. And on that loan, each month they will pay in the future, they will pay each month 5%. So let's label that loan Y1. So also now you can see that we have cash available in July. We'll have 20,000 plus X1 plus Y1, but we'll need to pay the 60,000. That's our liabilities. And our goal is to make sure that our revenues, including the loans, will allow us to pay the liabilities. Now, if we have any leftovers, this will be the amount that we'll carry for the next month. So you see, I'm now defining all the loans that we take each month, but also we need to make sure that we are paying each month those loans. So if we took Y1 in July, we will need to pay it in August. It will become our liability. If we take Y2 in August, we'll need to pay it in September. So far, these are the illustration, and now let's see how we also add the amount that we carry over from month to month if we have a difference between our revenues and liabilities. So I'll define C as the carryover, and you can see if we have a certain carryover amounts, we can carry it from July to August, and then from August to September, and etc. So this is the visual representation of the problem, and especially in time-related model, this is what you want to start with. You want to visualize the case, and then from here, the formulation will be much more simple. The next step will be to define the variables. And as you can see, we already see the variables that we're going to use. We're going to have X1, which is the dollar amount that we'll borrow for the 6 months loan. We'll have YI, which is the dollar amount borrowed in months I when we are borrowing it every month, 1, 2, up to 6. And we'll have CI, which is the dollar amount carried over from months I to months I plus 1. So we can see that as well. So now we defined all of our variables, and the next step will be to define our objective function. So if you read the problem again, at the end of the problem is very clear, and it says that your goal is to minimize the cost of borrowing. Basically, the interest that you are going to pay on all the loans that you have borrowed. So in this case, we have one loan, X1, that is for 6 months, and we will pay 11% interest. And then for each month that we're taking Y, I will pay 5%. So here is the representation. You can also use a shortcut notation using the following formula, using summation for YI. So this is your objective function. The next step will be to define the constraints. Now, the constraints will be the balance between revenues and liabilities to meet the cash flow for each month I. And for example, if we'll look at July, we see that our revenues are 20,000 plus the amount from the loan that we're taking X1 and the amount of loan Y1. So these are our revenues, and we have liabilities of 60,000, and we have amount carried over from July to August, which is C1. So if we'll write that, and basically what we follow is we're looking at inflow to July, and we make sure it's equal to the outflow from July. So here it is, X1 plus Y1 plus 20,000 needs to be equal to 60,000 plus C1. And obviously we can rearrange it, move all the variables to the left-hand side and keep the constant values in the right-hand side. So this is July. Let's look at August. So in August, we see the inflow are 30,000, Y2 and C1, and the outflow are 60,000, Y1 and C2. So we're writing inflow equal to outflow, and then we are rearranging it to the constraint. So if you follow this, and you need to do it 6 times from July to December, basically for these 6 constraints that represent inflow equal outflow, you will get the following list of constraints. And obviously this list is not organized with left-hand side and right-hand side, but you can write it into on a piece of paper and reorganize it yourself. Now we're not done with these constraints. We have 2 more constraints to take in consideration. Obviously, one of them will be the non-negativity, but let's see another type of constraints that we need to apply here. And we need to deal with what happened at the end of these 6 months. So dealing with the end. And what we'll see is that in December, we took a loan of Y6. Obviously, at the end, we'll need to pay that loan. And we also will need to pay X1 eventually. And we also will need to make sure that the carryover amount is enough for us to pay these loans. So what we'll see is, again, what we're looking for is that Y6 and X1 will be at least either less or equal to C6. And that's our constraint that we call it the end constraint. So I can reorganize it. It looks like this. And obviously the non-negativity. So if you look at all of your constraints, you're ending up with this list of constraints, and at the end, the non-negativity. So I hope this illustration of time-related models with the visual way of demonstrating the inflow and outflow, especially in loans and cash flows, it's very, very helpful to do that. And from here to move to Linear programming, it's much more clear and simple. Thank you.